Welcome warmly to second part of the interest rate parity, where I start with an interest rate parity example. Um, this example allows us to see the full exercise one more time with numbers before we did with formulas and with words. The numbers are that 1 year Japanese bonds are paying us 4% interest. So we write Rf equals 0.04 as we write the 4% in decimals, not as 4 but as 0.04. 1 year US Treasury notes are paying us 8% interest. So if we loan our money to US government for 1 year, it's called a Treasury note. If we loan it for 11 months, it would be called a Treasury bill. And if you loan our money to US government for 2 years, it would be a Treasury note. And if it's 10 years, it would be a Treasury bond. All these US obligations are discount bonds. A discount bond means that right now you pay less than 1,000 for it, and at maturity you get $1,000, which is interest and principal. So if you buy it for $970 today, and after a year you get $1,000, the extra $30 is interest payment. Discount bonds. That's a good definition to know. Discount, as the word implies, means the price of the bond is less than 1,000. As I said before, uh, almost all the bonds we deal with are 1,000 euros, $1,000. So when the price of a bond in the marketplace is less than 1,000, we call it a discount bond. When the price is more than 1,000, we call it a premium bond. And when the price of a bond is 1,000, we call it a par bond. The word par comes from golfing. If you are golfing and you have par 4 and you do it in 4 shots, it means you have done it normal, neither great nor bad. All right. Then we go to a spot rate, the rate for exchanging yen against dollar in the cash market or right now on the spot. And that's given to us as 120 yen per dollar. Because this rate is given per dollar, we figure out that dollar is domestic. If this rate was given as so many cents per yen, then Japan would be domestic. So RD here is US interest rate of 8%. And the foreign interest rate is the Japanese interest rate of 4%. So we know this after we know yen and dollar spot rate. We write it as S equals 120 yen per dollar. 1 year Japanese yen per dollar forward rate is 114. In other words, F, which stands for forward price, is 114 yen per dollar. Let's continue with this Harvard Business School lecture note exercise. The next question to ponder together, to ask ourselves, is dollar at a forward premium or a discount? Think of this question a minute. It helps us understand this concept of premium or discount. Forward premium meant that the price of dollar in the forward market is more than the price of dollar in the spot market. And forward discount meant less. Well, The price of the dollar is given in yen. The forward price is 114 yen. The spot price is 120. So we are expecting dollar to go down from 120 yen to 114 yen or get cheaper in the forward market a year from now. Therefore, we say we have a forward discount. This is a typical exam question, and answering it is quite simple. You compare F to S. If F is less than S, you say you have a forward discount. If F is more than S, you say we have a forward premium. Also in my lecture notes, we did F divided by S. If you divide 114 by 120, you get a number less than 1, and that means a forward discount. Does the interest parity hold? My exam would also ask you this question. Well, to answer this question, I should know the interest rate parity IRP by heart. I should be able to write this equation. The equation was F divided by S equals RF divided by RD. To memorize this equation, as a student, I did a funny mind trick that helped me remembering it. On the left-hand side, we have future divided by a spot. On the right-hand side, I often wondered if RD or RF comes first. And my funny way was saying we are hospitable and we let the foreigners go first and then the domestic people come. So we have 1 plus RF, the foreign interest rate, divided by 1 plus RD. A funny way of thinking about it, but it makes me remember the equation. Anyways, this is equation you should know by heart. Once you wrote the equation, you start putting numbers in it. Well, the equation said F, and F was given as 114 yen per dollar, divided by S, which was 120 yen per dollar, equals to, and I put a question here because I don't know if the equality holds or not, 1 plus RF. RF was the interest rate in Japan and it was 4%, so we write it as 1.04, divided by 1 plus RD. RD was the domestic interest rates in US and 8%, so this is 1.08. To answer this question, if both sides are equal, we simply use our calculators, and again remember to bring a calculator to my exam, and we divide 114 by 120, and that gives us an answer of 0.95. And we divide 1.04 by 1.08, and it gives us an answer of 0.96. Then the question is 0.95 equal to 0.96? And the answer is obviously no. The two sides of this equation are different. So we say interest rate parity does not hold. Often an interesting question comes out from students at this point: how many digits should I go? This question has a simple answer. In my exam, it doesn't matter. I don't deduct points or give you a less grade if you don't go many decimal points. But there is a precise engineering answer. The engineering answer is the number of decimal points that you go talks about the precision of the input data that you had. So if I go 10 decimal points and I measured my lengths using this plastic tape that comes in my sewing machine, then I'm exaggerating. That tape is not accurate up to 10 decimal places. That tape may be accurate to 1 centimeter. So if I'm giving numbers in meters, I can go 1.20, 120 centimeters, but not more. But if I had a microscope or atomic microscope, then maybe I'm allowed to go more decimal places. Another typical answer you receive is two decimal places for exam purposes, but the engineering answer is really the right answer here. Decimal places depends on accuracy of our measurement. So here, if numbers are 1.04 and 1.08 divided by each other, the answer will go two decimal places, 0.96, even though that our calculator has the ability of spitting out many more decimal places that we don't need or shouldn't use. So the answer is the parity doesn't hold because the two sides are not equal. 0.96 is greater than 0.95. Remember that we were doing arbitrage. As my first lecture, triangular arbitrage, taught us, we are purchasing something cheap and then we are selling it expensive and we are making an arbitrage profit. Of course, we learned this whole thing in order to learn more international financial risk management. We didn't learn it to make a profit. In fact, arbitrage is a job, and usually arbitrageurs work for a company. So here we are looking for a rate that is expensive, price of something that is high, and price of something that is low. Well, that something is interest rates. We are asking ourselves, are interest rates too high or too low in US and Japan? You would say the answer is obvious. 8 is more than 4. Americans charge 8% interest and Japanese charge 4% interest. No, that's not the right way of doing it. Because if you borrow at 8% interest and later on in forward markets, American currency dollar becomes much cheaper than yen. When you make your yens to dollars to pay off this loan, your yens may buy much more than 8%. And then you wouldn't have an 8% extra cost. Therefore, it is important to consider what happens to the currency of a country. And that's, of course, in the left-hand side of our equation. It gives us a forward price, what happens in the forward market, and this forward price is something you have today. This is an important point. We could go to a bank today and get into the contract to purchase Japanese yen versus American dollar at this fixed rate of 114. Of course, this fixed rate comes based on demand and supply. How many people show up at that bank? And that rate is different from 120. All right. So the interest rate parity doesn't hold. Interest rates are expensive in one country and cheaper in the other country. But we are not just comparing 8 to 4, but we are paying attention to what happens if we get a loan at 8% and later on we have to pay it with dollars. Considering that dollars have a forward discount, they would get cheaper. And this is a fine point that also goes with international loan crisis and a risk of these international loans. Um, for example, the Latin American countries decades ago, in a hard way, figured out that if they have borrowed in hard currency, mostly dollar, and if that currency had become more expensive later on during the life of the loan, this would create a risk and would. All right, we want to do arbitrage. Before we proceed on arbitrage, it's useful to consider whether arbitrage is an activity that generates wealth in for the society as a whole. So far, it sounds like a greedy person would purchase something cheap and then would sell it expensive and would make profit, and that's arbitrage. A related question is, should arbitrage be legal? Should the financial authority or government allow arbitrage? This question is not theoretical, it's practical. And a good place to take this question is to product markets. Imagine that in the villages there are tons of apricots ready to be harvested, but the harvest time is short. And many of them would perish if they're not purchased. The price is relatively low in these villages because supply of apricot is so huge. Let's make it an extreme example and say the price is 5 cents a kilo. And then let's go to the large city, Mexico City or Moscow or what have you. And let's say the price of apricot in the large city is 2. Let's do our prices per euro, 2 euros per kilo. Now a merchant will go to the villages and purchase apricot for 5 cents per kilo, put it in the trucks and train and transport it, take it to the large city and sell it for 2 euros per kilo. That's arbitrage in product market. We did arbitrage in foreign currency market when we had triangular arbitrage. And of course, you could do arbitrage in financial markets, for example, with bonds and other instruments. Okay, back to our apricot story. It's not just one merchant. Other merchants would hear about this. There is competition. You can buy apricots for 2 cents and sell them for 2 euros per kilo. So they show up at the village and start buying a lot at 2 cents and take it to the large city and sell it at 2 euros. Eventually, this increased demand in the villages would raise the price. The farmer sees a lot of people wanting um, his or her product, and the price will go up from 2 cents to 3 cents, 4 cents, and eventually will go higher up. And in the large city, as many merchants bring this um, 2 euro per kilo apricots, the price starts being discounted. Customers aren't buying as much, the grocery stores start discounting it, the wholesale price falls. And you see that an equilibrium price emerges where the price at the villages will go up toward 1 euro. Um, we can imagine that, and the price in the city will go down toward 1 euro. And the only difference in prices would be a transportation cost and a fair profit for an intermediary who has labor force and takes the product from the farm to the large city. So we see that in this case, arbitrage is useful. If you ask what this merchant does and why is it useful and why arbitrage is useful, you would say that arbitrage gets rid of price discrimination. Why should the poor farmers face a low price and the poor consumers in the large city face an exaggerated high price? Of course, this example, the act of being a wholesaler, is mixed together with the act of being an arbitrager. But in our triangular arbitrage, these two acts were separated, and our arbitrager was working pretty much like you and I on a computer, was or on phone lines, on internet, was quickly purchasing at a low price and quickly selling at a high price. And now again, we are stuck with what is the social benefit. Is it all greed or does it do something for the society? A good way to see that is to go to China as a laboratory. I was in China in 1997, if my memory serves me right, um, or it was probably 1998. Yes, this was at the time when Hong Kong was being handed over to mainland China, and I was a younger man then, and I was in a disco dancing. Um, at a certain time, they stopped the music, they stopped all of us dancing, and everyone very solemnly, very quietly watched the TV. All right, let me go back to my dancing after a pause. Yeah, they paused our dancing and they put a TV program on, and the TV program was about Hong Kong joining China, mainland China, and UK giving Hong Kong after a 99-year lease back to China. We watched this, and then there were some commercials, and these were very similar to our infomercials that we have. And this was about the life of a Chinese millionaire, one of those millionaires, his name being Mr. Wu. And this gentleman had um, started arbitrage. So here is Chinese government telling the citizens that arbitrage is a good activity because they are doing infomercial or commercials about it. They are glorifying it. Why are they doing this? Well, let's backtrack to the life story of this Mr. Wu. And early on, to when China moved from communism to free markets, one of its first acts was to issue government bonds. Government bonds are something that you saw in this lecture and you understand what it is. The Chinese government is borrowing from citizens. But what it really meant is everyone then worked for the government and they had a low salary. Um, let's say you're making 40 euros a month and you are a Chinese farmer, and government comes and says, from next month, I have government bonds and you have to buy one. There wasn't any market for it, so it was sort of people were forced. They were given their um, wages. Now it's not 40 euros, but it's 39. Of course, it was renminbi or yuan or Chinese currency. It's 39. And for the next one, let's just call it 1 euro. To make the example user friendly, you get a bond worth 1 euro. You're loaning 1 euro to Chinese government. You say, well, if I was a farmer, I didn't want to loan to Chinese government. Yeah, but the farmers had no choice, and of course they were scared of Chinese government. So they took these bonds that they had no use for and put it in a desk drawer, and it sat there. It wasn't money to them. Nobody wanted it. Mr. Wu started a business where he would go from village to village, sometime on foot, and purchase these 1 euro bonds. And of course, the purchase price wasn't 1 euro. The farmer was very glad to sell this thing, piece of paper, for some money. He would show up and buy it, and then he would go to the big city, Shanghai, sit under a tree where there were other traders like him, and they were trading bonds with each other. And of course, once these bonds mature, Chinese government would give you one, let's say, unit of their currency. So these things were not worthless, but you have to wait till maturity, and you have to value it now. So a price developed in this market, and slowly as more arbitrageurs like Mr. Wu showed up at the village and started buying these government bonds um, at cheap prices, the prices rose in the villages. And the price in Shanghai, more supply of these bonds became available, went to a reasonable amount. So, exactly like that example of apricots, the price discrimination disappeared as you got these arbitrageurs. That gets us to the story of what arbitrageurs do for the society. In a free market uh, system, arbitrage activity is a part of the puzzle of running these free markets smoothly, making sure that there is no price discrimination, making sure that there is no price anomalies, making sure that in different geographical locations we don't get two different prices for the same thing, except for some transaction cost and cost of transportation, etc. So everyone sees a fair price for bonds, everyone sees a fair price for apples, etc. So if in an exam or in a conversation outside of this class, someone asks you, what does an arbitrager do for the society? You would see that question in my exam too. The answer is they get rid of price discrimination. They would make the prices normal in different markets. They bring the prices in equilibrium in every market. Obviously, free markets are behind this reasoning that arbitrageurs are useful. If free markets collapse, if we don't have them, then this argument about arbitrageurs is not true either. For example, at the time of war or at the time of Corona, when markets are interrupted, um, someone could purchase a product cheap and hoard it, keep it, corner the market, and then sell this product expensive. And we usually make that activity illegal. Hoarding is an illegal activity. We are saying arbitrage at the time that the free markets are broken is not a desired activity. But arbitrage at the times that free markets are operating normally gets rid of price discrimination, so we see similar prices in different places. All right, so we have established that this arbitrage is an activity that should be allowed. The regulator should allow it in order to get rid of price discrimination. Now, here we want to do a more complicated arbitrage. We want to arbitrage interest rates. Let's first look and see which interest rate is cheap and which interest rate is expensive, because we want to borrow at a cheap interest rate, loan money at an expensive interest rate, and make an arbitrage profit. Going back to the equation that you have up here, you would see that 0.95 is not equal to 0.96. How can we make these two equal? Let's start with the right-hand side. Later we see that we can also start with the left-hand side. But for educational purposes, it's much easier for us to look at the right-hand side where it has the interest rates. So imagine that S and F on the left-hand side, these numbers stay the same, and they are 0.95. So what should happen for 0.96? So it goes down to 0.96. 95. Well, either 1.04 should go down or 1.08 should go up. If we divide by a larger number, we get a smaller answer. For 1.04 to go down, we are saying 4% is too much of an interest rate in Japan. It should be less than 4%. In fact, if you write 1.026 for 2.6% interest rate in Japan and you divide it by 1.08, you get 0.95 on this side. How did I get 2.6%? Well, instead of 1.04, I put an x here and I solved this equation. 0.95 equals x divided by 1.08, and x came to 1.026, so I wrote it as 2.6% interest. The one is to get the return. All right. So we are saying 4% interest in Japan is too low. This example was chosen on purpose. Harvard Business School lecture notes gave us these numbers, so we see 4 is actually more than 8, and that's surprising to us. Why is 4% interest rate is more expensive than 8% interest rate? Because if we borrow at 4% in Japan and later we have to pay for it, dollar, which goes to a cheaper rate, would buy us less yen, and then this loan would be more expensive. Dollar would depreciate by more than 4%. So we get hit by a depreciation of dollar of more than 4% and a value of interest of 4%, and that would hurt us more than 8%. So in this case, it is better to borrow at a rate of 8%. It's cheaper. In other words, 8% should go up. And then if you divide by a larger number, you get 0.95 in this side. It's nice to do this as an exercise. Put x here and see what number solves the equation. What interest rate instead of 8%, what cheaper interest rate, what more expensive interest rate in US would make this side 0.95, so parity holds. I would do this later on in this slide, but I would encourage you to calculate that x. All right, so we know that interest rates are cheap in one country. They are cheap in US in this example, 8% in violation of interest rate parity, and they are expensive in Japan, 4%, because once we pay our loan, we pay this 4%, we have to pay with foreign currency dollars that have become cheaper against yen, and we have to pay more yen and we would lose money. This is a very interesting idea that we learn in this class. Imagine you go back to work and your boss says, oh, interest rates are 4% in Japan, but right now they're loaning to us at 8% in US. Therefore, let's raise capital in Japan. You say, no, we can't just compare 4 to 8 and say 4 is less than 8. The correct way is to think what would happen to value of dollar versus yen when in the future we pay off our loan. If dollar becomes cheaper in the future and we have dollars to pay for our yen loan, then we may end up paying more cost with this 4% interest in Japan. Let's summarize this in this slide. What does it mean that a country has a cheap interest rate? or cost of borrowing capital is lower in a country. We are not comparing 4% to 8% and concluding that 4% is smaller than 8%, therefore 4% is a cheaper interest rate. So the moral of this story is in international finance and economics, we are not allowed to compare cost of capital, cost of borrowed capital in one currency against the other currency, just looking at percentages. We have to also consider what happens to depreciation or appreciation of currencies in the future. We are comparing the ratio 1.04 divided by 1.08, the ratio of the two interest rates in the domestic and foreign country, with the ratio F divided by S, with a ratio that tells us what would happen to the currency in the forward market in the future. So F is some indication of what will happen to the currency in the future. More importantly, F is available right now and we can lock that fixed rate for future payments, which is something that we would do soon. Divide this by S, which is the spot price for foreign currency here, dollar versus yen. We are comparing the ratio 1.04 by 1.08 with the ratio F divided by S and concluding that 4% interest rate in Japan is too high of a borrowing cost after accounting for yen per dollar forward and spot rates, or the ratio of 114 divided by 120. Therefore, we are saying 4% is too expensive when we realize the other side is a cheaper dollar in the future. 8% is a low borrowing cost after accounting for yen per dollar forward and spot rates. If we borrow in US, when we pay it later in cheaper dollars and we have yen to convert to dollars, then we don't lose 8%, we lose less than 4%. Okay, can we do arbitrage? Can we take advantage of cheaper interest rates in these two countries? We discussed what arbitrage was, a definition that you and I should know precisely. If this definition comes in the exam, you should mention 5 things. Usually I'm happy with 4 and give you full grade. 1 product, 2 prices, 2 different markets. We would like to purchase cheap and sell expensive simultaneously at a very short period of time, and we would have no business risk but execution risk. Usually that's enough. 1 asset, 2 markets, 2 prices, instant access to both markets, riskless arbitrage profit, and this riskless means business risk is not there, but there is execution risk, and the exam may ask you to define execution risk, and you say that's the risk that we place a market order, and by the time our order is executed, hits the marketplace, the prices have changed because of other arbitrageurs and other traders' activities, and we get a higher price for purchasing than we see, and a lower price for selling than we see from our Bloomberg terminal or from our data providers. Execution risk, what about it? It's always there, and I just defined it, and you should be able to define execution risk, or the risk of getting a worse price when your order is executed in the exam. Is arbitrage socially beneficial? I gave you the long story about Mr. Wu in China. Government of China at the time of communism considered arbitrage as a socially not beneficial activity. In fact, execution risk, this would be a sad joke. would have meant that the arbitrager would have been executed, killed. Um, uh, of course, that was a dark humor. But as the country of China moved from communism to uh, free market economy, there was move for arbitrage because arbitrage allows trading activity to take place in different markets, um, brings liquidity and brings the prices um, essentially to equality with each other in different markets. And I often refer to uh, Mr. Jung as Mr. Wu. Sorry about that. The gentleman's name, the millionaire who started bond arbitrage, was Mr. Jung, kind of like Yang, but his name often escapes me. But here I have it in writing. Covered interest arbitrage. So we are going to arbitrage interest rates, the price for borrowing money, or the cost or price of borrowed capital. And we are going to cover or buy, hedge, or insurance against the risk that the foreign currency changes. In a minute, you would see how the coverage works. What do the words mean? We want to define this covered as hedging or insurance, and of course, interest arbitrage means that we are taking advantage of cheap interest rates and borrowing at those rates and making them available at higher interest rates as a loan. Let's do an example. We borrow at the cheap US interest rates of 8%. Let's borrow 10 million US dollars. Again, someone who does that is usually a multinational company and um, can deal with large amounts of money. If we borrow $10 million from an American bank today, we would receive a positive cash flow at time zero of $10 million. But at time one, which is a year from now, we have to pay this money back and we have to pay 8% more as interest. So multiply $10 million by 1.08. That would give you the payment, and the payment to borrower is a negative cash flow, and to the bank is a return. Okay, so our obligation or cash flow at time one is negative. We have to pay 10,800,000 next year toward this loan. Now we take this money and we make it to yen. Therefore, we need to deal with the spot market. In the spot market, uh, you have a rate of 120 yen per dollar, a rate that was given in this example. Exchange the borrowing in US dollar to Japanese yen at the spot rate of 120 yen per dollar. All right. So for $10 million, we multiply by 120 yen per dollar. For $1, we get 120 yen. For $10 million, we get 1,200,000,000 yen. Lots of yens. Now we take this yen to Japan, to Japanese markets, and we make it available for a loan. We purchase government bonds, which in effect is loaning this money to Japanese government. Loan 1,200,000,000 yen at 4% interest in Japan. Because the problem told us that the yen interest rates are 4%. This means after the loan matures, which is a year, we get 1,200,000,000 yen multiplied by 1.04, or we get 1,248,000,000 yen next year. All right, let's backtrack and look at our story. We started this discussion with borrowing money, so next period we have to pay it, and that's 10,800,000 that we have as an obligation to American banks. We took all our money and took it to Japan and loaned it, so right now we have no money. But next period, Japanese would give us 1,248,000,000 yen. Is this money enough to pay Americans their loan and the amount that we borrowed from them in dollars? Well, yen and dollars would fluctuate against each other next year. And these fluctuations um, are random. So no one knows for sure what yen and dollar would do to each other. But we could lock in this deal at a fixed price, and that was a forward contract. The forward contract said that at a fixed rate of 114 yen per dollar, you could purchase dollars a year from now in the future. So, how many dollars should we purchase in the forward markets? Well, enough to pay off the American loan. The American loan was $10,800,000, and we go to the forward bank and sign a contract today to receive 10,800,000 from that bank in dollars, and they promise to pay them yen at the current published available forward rate of 114 yen per dollar. Multiply $10,800,000 by 114 yen for each dollar, so we have to give 1,231,200,000 yen next year, and the bank has to give us $10,800,000. The bank's money will go toward the American loan. Our borrowing next year, um, our yen payment would come from the yens that we earned. But we earned more than 1,231,000,000. The rest is an arbitrage profit. Here is the arbitrage profit. The borrowers in Japan would give us 1,248,000,000 yen, and we give 1,231,200,000 yen to the bank. The difference is 16,800,000 yen of arbitrage profit. All right, so we were able to specify an arbitrage. This arbitrage affects the prices. Same way that triangular arbitrage made the cheaper prices more expensive, or arbitrage in apricot markets, as cheaper apricots are purchased in villages, made those prices go higher. Here, as more borrowing demand goes to US market because their 8% interest rate is too cheap, given the fact that their forward rates indicates a cheaper or a discount compared to the spot rate. Um, this demand would not be from us individuals, usually from multinational companies that raise capital at a lower cost of capital, and that in this example it's available in US. If you place an x for this 8% in the equation and keep the other numbers the same, the interest rate parity would hold at 9.47%. This is a good exercise to do. I go back to the interest parity equation that we had a while back. Here is the equation. So you would keep the 0.95 and you would say it equals to 1.04 divided by x. 1.04 divided by x should equal to 0.95, then both sides would be 0.95. And then you solve for x. Let me go back to the lecture at the point we were. Please do that exercise and x should come to 0.0947 or 9.47%. Interest at US would be a fair interest rate or fair cost of capital compared to 4% interest rate in Japan, and the other 5.47% cost is reflected in the fact that Japanese yen becomes stronger in forward markets, or is at a premium in forward markets. Remember that when we say US dollar has a discount in forward market, the opposite holds for Japanese yen. It has a premium in forward markets. Increased arbitrage borrowing supply in Japan reduces the rates under 4%. Our arbitrage called for borrowing in US and going and lending this money, making it available for people who want credit, who want capital in Japan. As multinational companies do this, more funds become available as capital in Japan, and the interest rates would go under 4%. We did this exercise before. If instead of 4% in that previous equation, we put x and we keep all the three numbers as they were, well, actually two numbers, then we would get 2.6 for that x. Of course, we could also play with the other side of the equation. Let's see what I mean by other side of the equation. Let's go back to this equation. So far, we said 1.04 divided by 1.08 should equal 0.95, and therefore we either put x for 1.08 and we get the equilibrium value for it. Solve the equation 1.04 divided by x equals 0.95, or we put x for 1.04 divided by 1.08 equals 0.95 and figure out what that x would be instead of 4% to get equilibrium. But here the left hand side could also change. We mean this 0.95 can go up to higher to 0.96. For it to go higher, 114 should go higher. So put an x here, divide by 120 and say it's equal 0.96 and calculate that higher value. Or 120 should be smaller. If we divide by a smaller number, we get a higher number than 0.95, and therefore left hand side will go up and would be in equilibrium. And we can put an x here and solve the equality 114 divided by x equals 0.96 and figure out what that x is. Again, I suggest that you do this as an exercise. Let's go back and see it here. Sale of US dollar for arbitrage purposes at the spot market makes dollar weaker at 118.75 yen per dollar. Parity holds. Um, so that X should come to 118.75, and purchase of US dollars at forward market for arbitrage makes dollar appreciate at the forward market. So instead of 114, the X goes to 115.2, and I encourage you to calculate these X's. So if F is 115.2 instead of 114, and if S is 118.75 instead of 100 and instead of 120, if it goes down to 118.75, the parity holds. So we had four values in that parity equation. F divided by S equals 1 plus RF divided by 1 plus RS. Any one of these four could change if the other three are constant. In fact, the other three don't have to be constant either. All these numbers can change due to arbitrage activity. It was easier in the classroom to keep three of them constant and do an exercise for you. As long as these numbers change, so the parity holds, then we get to a situation where arbitrage is not possible. One or a combination of all can happen, and then we go to a situation that there is no arbitrage. Let's discuss some problems with this arbitrage. Some of these problems we already have seen. We have seen them in triangular arbitrage. Some of them are new. Here is a new one. Borrowing and lending rates are different. If you and I go to borrow money from a bank, they give us one interest rate. For example, 2% on our loan. And if we deposit our money in that bank, or we put it in a term deposit that says the money would be there for a year, that's the same as making this capital available as a loan that earns interest. The bank would loan it to others. They don't give us the same borrowing interest rate. In fact, many of these accounts are making close to zero or very small value. That's this problem, that borrowing and lending rates are different. What do we do about this problem? Because remember, in our arbitrage, we borrowed in US and then we lent in Japan. Now we only had one interest rate. Is that one interest rate for borrowing or for lending? Which one is it? This is very similar to the bid and ask difference we had. There were two prices there. There are two prices here. But the two prices are not so different as my example of individuals indicated. Because if we go to large credit-worthy companies, their borrowing and lending rates become more and more similar. If we go to a large government, their borrowing and lending rates become more and more similar. They start borrowing at rates close to interest rates available in the society for our borrowers or with best credit. So part of difference between borrowing and lending rate is when I borrow from the bank, I don't have a very good credit rating. But when I lend to the bank, this money is quite safe, and as a matter of fact, is guaranteed by the government. Therefore, the interest rate has a lower amount of interest. Default premium is added to interest rates. As we are more likely to default or we have more risk, we pay a higher interest on our loan. So when I was using an example of an individual, their lending, if they deposit their money in the bank, the lending rate is almost zero interest um, added for um, default risk or zero default premium, and in their borrowing rate, an individual has a high default premium. So it's not fair to compare this. But if we do it for a large company with high creditworthiness, these two rates get closer to each other. Second, bid and ask prices are different. I did a lecture on bid and ask. Bid is the price to buy, and ask is asking price for selling dollars, and this is from the point of view of the dealer. So we should have two different prices. The traders usually don't, and we don't either. One considers this as a certain amount of interest difference, um, which is known by experience, is uh, to be tolerated. After that, one can take advantage of interest differentials and go to different countries and get interest or cost of capital at a lower amount. Bankruptcy is a point. What if Japanese go bankrupt in this case and don't pay us the loan back? The best way to deal with bankruptcy is to go after government bonds that mm, are almost riskless. Nothing is risk-free in our human life, but we have to wave our hands and take something as uh, riskless because it has less risk, and usually that's the bonds of a major industrialized nation such as Germany or US, and we adjust this for um, risk that credit rating agencies say that some governments have. So bankruptcy risk um, it also needs to be considered. So our solution for this problem, can we really do interest rate arbitrage, is you and I as individuals perhaps not, but large multinational companies can do it. Also, they don't have to do it exactly the way that this exercise is stated. A multinational company that is about to borrow in Japan at 4% interest rate could switch their borrowing to US. Not borrowing in Japan would make more funds available to Japanese borrowers because the demand of this one company dies down. And as they switch their borrowing to US, they borrow more in US. The demand for borrowing in US at this um, cheap rate of 8% in violation of interest parity would increase. This activity of multinational corporations switching their borrowing from one country to another country is equivalent to arbitrage, and this affects the interest rates of those countries. Of course, they exchange the money to yen and they can take it to Japan for their operations and make it available there. They sell yen forward to pay their loan if their business has income in yen from Japan. So all these activities can be done by a multinational company and usually is done. And therefore, this interest parity, except for a transaction cost, except for a slight difference, would hold in international markets. Interest rate parity holds with multinationals switching borrowing to cheaper countries. Multinational borrowing in US pushes the cheap US interest rates higher. Multinationals switching borrowing out of Japan helps reduce demand for capital there, and this pushes expensive Japanese rates lower. Forward contract purchase of dollars increases its forward price. A spot sale of dollar reduces its spot price. All right, back to your exercise, interest rate parity exercise. Please do this exercise after you read the lecture. Of course, you can email me and ask questions, but by the end of the day today, I should receive this exercise from you. And there is attendance and associated grade attached to it. 1 year Japanese bonds pay 2.5% interest. 1 year US Treasury notes pay 8% interest. Japanese yen dollar spot rate is 120. Japanese yen dollar forward rate is 114. The first question is dollar at a forward premium or discount? The next question is, does the interest rate parity hold? Please answer that question by writing the equation. Then figure out which interest rate is too high. Then do cover interest arbitrage. Borrow at the cheap interest rates and do a 10 million yen loan. Then sell yens and buy dollar at the spot market. Loan in the USA and buy yen 1 year forward to cover your loan and finally show an arbitrage profit. As you see, there are some hints there in some of these slides. I want you to have one quick exercise which is easy and teaches you the material that we just covered. Our second exercise is more real world. It says look up the exchange rate and interest rates from internet for two countries. Pick realistic numbers for two industrial countries of your choice. Do not have to go with exact coded prices, but stay relatively close to reality, and then see if interest rate parity holds. Change the rates slightly so that your work is different from your classmates' work. You could mass email to me and classmates, and or private to classmates and ask them about their work. But by the end of this day, you need to have a work that is different from theirs and shows real interest rates in the world, and then you show a profit from arbitrage activity. Thank you for your time, and I hope that you have enjoyed this lecture.